So today we're going to look at some optimization problems. The first one is a farmer wants to build an enclosure to keep his cows safe. He needs to fence 3 sides of the rectangular area as the 4th side is bounded by a river. The amount of fencing available is 100 meters. Determine the dimensions that maximize the area of the enclosed field. Now this question is on the handout that you're probably working through. So if you need to see it more clearly, it's also listed there. So the first thing that you need to do is figure out what we are being asked to optimize. So I've written down here that we are optimizing the area of the rectangular area for the cows. And then we need some let statements and a diagram if applicable. So that's identifying the unknowns and drawing a diagram. So we're going to let area be length times width, represent this area of the enclosure. And our diagram here is indicating that here's the length of the enclosure and the width, but we don't need a second length because the question indicates that there's only 3 sides because it is bounded by a river. So we have the river down here. So next we are identifying the function that we need to optimize. So that's the area is equal to length times width. But this has 2 variables. We can't just take the derivative if we have 2 independent variables over here. So we will need to try and work that out at a later point in the question. But before we do that, what we want to do is identify the restrictions on the variables. So since we have 2 variables here, we can either state the restrictions of both variables or state the restrictions after we've eliminated one of those variables. It's up to you. So I've done it here. We only have 100 meters of fencing, so that means either a length has to be between 0 and 100 and or width has to be between 0 and 100. Obviously, they both can't be 100. So what we need to do in order to try and eliminate either an L or a W is use the other information, that number 100. And if we take a look at our diagram here, we can see that we have 2 widths, 1 length, and only 100 meters of fencing. So we can use the perimeter is 2W plus L, and we know that the perimeter is 100. So I've used this equation, and we often call that the constraint equation. And we are rewriting it so that we have L is equal to 100 minus 2W. And we can use that equation to substitute into our equation from up here so that we get area is 100W minus 2W squared. And now we only have our one variable on the one side, that's our independent variable, and our area variable on the left-hand side. So easily to be taken the derivative of that. So our 6th steps is that we're going to take the derivative of this function because that's the function we need to optimize, and then we're going to set to 0 and solve. So the derivative was fairly straightforward on this one. I just used my polynomial rules, and then I indicated that I was going to set my derivative equal to 0, and I solved, and I got W is equal to 25. So then we have our 7th step, and our 7th step is to check the zeros of the derivative and the end points to see if we actually have a maximum. So that's step 7 over here. So variable W goes from 0 to 100, and we know that 25 was where it was a 0. I chose the number 5 and substituted that into my first derivative here. So that's 100 minus 4 times 5, so that gives you a positive number. And I substituted 90 into the same formula, so that's 100 minus 4 times 90, which is obviously a negative value. So we know that the function was going up, it's increasing, and then it has a maximum, and then the function was decreasing afterwards. And the number 25 is definitely between 0 and 100. I just have a note here that if W is 100 or 100 or 0, the area is 0, which is just a quick check on the end values 0 and 100, because we know that sometimes the end values can be maximums as well. So then we have to figure out the other dimensions. So if W is 25, then we know that the length is obviously going to be 50. To answer the final question, the dimensions of the enclosure are 25 meters by 50 meters.